Welcome to Properties of Logarithms. Today's objective is to use properties to simplify logarithm expressions and to translate between logarithms in any base. The first property we're going to learn about is the product property of logarithms. Now, the logarithm of a product is equal to the sum of the logarithm of its factors. So, for example, if we had an expression log base 3 of 100, we can break that down by breaking down the products of this term right here. So that's equal to log base 3 of 10 times 10. So we said the logarithm of a product is equal to the sum of the logarithm of its factors. So we can further break that down to say log base 3 of 10 plus log base 3 of 10. So this is how we use the product property to simplify this out. So if we want to write this in algebraic terms, we know that the log of some base times the product of two terms is equal to the log of the base of the first term plus the log base b of the second term. And we can use this in reverse too. So let's say, for example, we had an expression such as log j plus log a plus log m. These all technically have the same base, they're all common logs. So we can use the reverse of the product property. So we'll just do the reverse product property. And we just combine these. So that'll just be log of j, a, m. So it works both ways. We can either go from adding all the logs together to combining them into one, or taking one and breaking them out. In this example, we have two logarithm functions that are being added together. Now, for us to combine two logarithms using the product property, or any property really, first thing we have to make sure is the bases are equal. So here both of the bases are 4, so we're good. So right here we have the reverse product property. So here we're using the product property. Which says that the logarithm of a product is equal to the sum of the logarithms of its factors. So what we can do is we can combine these two. We can say log base 4 of 2 times 32. Now we know log base 4, 2 times 32 equals 64. So in some cases, if this function didn't even out perfectly, it would be done here. But we have to think about the fact that logarithms are the inverses of exponents. So let's think about this in exponential form. So our question is, what do we have to raise 4 to get 64? Well, when we put it like that, we easily know that 4 raised to the third equals 64. So the answer to this logarithm, log base 4 of 64, equals 3. Sometimes it's helpful to write these as exponential functions and to see what the actual answer is. Let's try a few practice problems out. So for our first example here, we have log base 5 of 625 plus log base 5 of 25. So both of these have a base of 5 and they're being added together. So we're good to use the product property. So we have to combine the 625 and the 25. Now when I do that, I have log base 5 of 15,625. So we have to think about what do we have to raise 5 to get 15,625. So we simplify this out and we know that we have to raise this to the value of 6. So 5 raised to the 6 gives us 15,625. Okay, for the next example, we have the same base of 1/3, so we have log base of 1 divided by 3 times 27 times 1 over 9. So this actually simplifies out a little easier. 27 over 9 is 3. So, trying to figure out what to raise 1/3 to get 3. And we know all we do is just flip the 1/3. So the answer to this one is -1. So these are both examples of the product property. So when remembering some of these logarithm properties, it may be helpful to think about the exponent properties. So in some of the exponent properties, for example, if you had two terms with the same base being divided by each other, what you would do is you would subtract the exponent values. So the quotient property is exactly that. You have two logarithms that are being divided by each other, so you subtract the properties. So for example, let's say we had log base 5 of 16 divided by 5. So what would happen here, this would break down to equal log base 5 of 16 minus log base 5 of 5. And that's how we use the quotient property to simplify out certain quotients. Now, I would do this out more, and I know that log base 5 of 5 is 1, but for now, this is the first step that I want us to get accustomed to. So in algebraic form, if we have a log of some base of some fraction, what we can do is we can break that fraction up into two logarithms. So log base b of m minus log base b of n. So for the product or the quotient property, if it's helpful, think about the exponent property that it comes from. Let's look at subtracting logarithms. So here we want to express log base 2 of 32 minus log base 2 of 4 as a single logarithm and simplify if possible. Okay, so since we're subtracting, we know we're going to be using the quotient property. So the first thing I want to know. So we're going to use the quotient property. Alright, so I have these two logs, they both have the base of 2, so I'm going to combine them. I'm going to say log base 2 of 32 over 4. Now I can do that math out easily in my head. Log base 2, 32 over 4 is 8. So this is a simpler logarithm to figure out. We think about what do we have to raise 2 to get 8, and we know the answer is 3. Because 2 raised to the third equals 8. So my answer here of log base 2 of 8 equals 3. Let's do one more practice problem. So same deal, we have two logarithms, we're subtracting them from each other, and the bases are equal. So since the bases are equal, and we're subtracting them, we can make them into one fraction. So 49 over 7 is 7. log base 7 of 7. Now we know if we ever have a log with the base the same as the number that comes after it, that just equals 1. And we know that because it's basically saying what do we have to raise 7 to get 7? And the answer to that is just 1. So log base 7 of 7 equals 1. Okay, let's look at an example of a logarithm raised to a number and see where the power property of logarithms comes from. So if we had an expression log 10 raised to the 3, let's think about what that means. Well, what that means is log of 10 times 10 times 10. Now we learned that the product property says that if we have a log and products, we can just split that up using addition. So we have log 10 plus log 10 plus log 10. So technically what I have here is log 10 added 3 times. So what I can do is I can say it's just 3 times log of 10. Since I have 3 log 10s that are being added together. It's like if you had x plus x plus x, you can just say that's 3 times x. But what we want to do is we don't necessarily want to do all these steps out in the middle. So let's look at our final expression and our beginning expression. And if we do that, we see, oh, well, all that really happens is we take whatever number this is here and put it out front. And that's the power property of logarithms. So, if I have a logarithm base b of subquantity a, and that quantity a is raised to a power, if I want to use the power property, all that means is I take that p and I put it out front. So it becomes p times log base b of a. So all we do is if whatever quantity a is raised to, we just take that power and put it out front. These are basically multiplied by each other here. Let's take a look at 2 logarithmic functions and use the power property to help us simplify. So in our first example here, we have log base 3 of 81 raised to the 2. So the first thing I want to use is the power property because I want to help get that 2 out of the way. So I'll bring that 2 to the front, and then it'll be 2 times log base 3 of 81. Now, this can be simplified here, log base 3 of 81, because I'm trying to figure out what I have to raise 3 to get 81. I know that if I do 3 raised to the 4, that'll equal 81. So this part here simplifies to 4, and my final answer is 8. Alright, for our next example, we have log base 5 of 1/5 raised to the 3rd. Same thing, first thing I want to use is the power property. Whenever you see something raised at the end there, you probably want to use a power property first. So, I'll bring that 3 out front. Then I have log base 5 of 1/5. I can simplify this because I know all I want to do is flip that 5 around, so I have to raise it to a -1. So 3 times -1 gives me -3. Now these are examples of using the power property to simplify logarithm expressions. It might be helpful here to pause the video, maybe try to do a few of these, and then when you come back I'll help you do the rest of them. So if you want to take a second, pause the video and work on these. I will be doing them strictly after. But if you're still struggling with them, just keep watching and I'll work through these. So for the first one, we have log 10 raised to the 4. So we move that 4 out front. We have log 10. Now this is a common log because there's no base 10. So really, think about it, there's a 10 here. So we're trying to figure out how to get 10 to be 10. So we have to raise 10 to the 1. So it's 4 times 1. The answer is 4. For the next one, we have log base 5 of 25 raised to the 2. We bring the 2 up front. We have log base 5 of 25. We know to get 5 to be 25, we have to raise 5 to 2. So which is 2 times 2, which equals 4. And for our last one, we have log base 2 of 1 over 2 raised to the 5th. We bring the 5 up front. We have log base 2 of 1/2. So to get 2 to be 1/2, we have to raise it to a -1. So we have 5 times -1 equals -5. There may have been 2 inverse properties that you have noticed by now, but let's make sure we're aware of what both of they are. So let's say that we have log base 10 of 10 raised to some quantity 3. Now what this is saying is, what do we have to raise 10 to equal 10 raised to the 3? So that's just, the answer is 3. So that's asking us, okay, what do we have to raise 10 to get 10 raised to the 3? So if these bases are equal, then the exponents are equal. So if we have a log of a base raised to that same base raised to some value x, the answer is just x. Alright, now if we have some base here raised to the logarithm of that same base of some quantity, if these two numbers are the same, then the answer is just 2. So if we have some base b raised to the log of that same base, the answer is just this value here. Let's see if we can recognize the inverse in these 3 following logarithm expressions. So for this first example here, we have log base 8 of 8 raised to 3x plus 1. Now since those two bases are equal, our answer is just 3x plus 1. On our next example, we have log base 5 of 125. So we're going to have to rewrite that because we want the bases to be similar. So 125 breaks down to be 5 times 5 times 5. Those two numbers multiplied together give you 125. So we can rewrite 5 times 5 times 5 as 5 raised to the 3. Now, since these are equal, our answer is just 3. For our last example here, I actually want to rewrite this because it didn't come out as clear as I wanted to. So we have 2 raised to the log base 2 of 27. Now, since these bases are equal, we know using the inverse properties that our answer is just 27. In this section, we've learned a few different properties to help us distribute and simplify logarithms, but sometimes those properties won't work. So what we have to do is change the base of the logarithm and simplify it out on our calculators. The formula we're going to use is called the change of base formula. And the way this formula works is if we have log base b of some quantity x, what we have to do is we have to break that out into a fraction. Now that fraction is log of some common base a of x, so that's the quantity that we have here, divided by log of some common base a of b, so whatever that base is. So let's look at our first example here. Evaluate log base 9 of 27. So we have log base 9 of 27. So we have to break that down. So since we have a's right here, we're going to give this a common base of 10. Now we use 10 because we can use 10 in our calculators to figure it out. So we're going to have log base 10, so we're going to write that, of x. X here is 27. Then on denominator we have log base a of b. So we have log base 10, so we don't have to write it, over 9. Now if you punch it into our calculators, we see that we get 1.5 as our answer. So let's try this one over here. We have log base 8 of 16. So since we can't simplify it the way it is, we use the change of base formula. So we have log base 8 of 16. So we use change of base formula. We're going to change both to a base of 10. And on the denominator we have this 8. And on the numerator we have the 16. Now, don't make the mistake of just saying it's log of 2. We don't just divide 16 over 8. We actually have to put log 16 in our calculator and divide it by log of 8. And when we do that, we see we get 1.33, and then it repeats. So we'll just round it off there and say 1.3. So once again, don't just divide 16 over 8. You actually have to put both of those values into your calculator. Okay, that's the end of properties of logarithms. I hope this was helpful. Take care. Have a good day.